Hello everyone and welcome back to CodeChef. Now it's time to learn how to actually fix errors or bugs in C++. In this video, we'll explore print statement debugging, common bug patterns in C++, and simple strategies to track down the root cause of a problem. If you have ever wondered how professionals debug efficiently, this video is for you. Let's get started.
Print statement debugging. Print statement debugging is one of the simplest and most powerful ways to understand what's happening inside your program. You add temporary cout statements to inspect variable values, loop iterations, conditional flows, and function calls. So in print statement, we are basically giving hints to the user for possible errors, which helps in inspecting variable values, loop iterations. Basically, it gives ideas about in which part of the code the error can occur. Now let us go to the CodeChef platform to see an example of print statement debugging. Here the program objective is debugging day progression. So in this example, we demonstrate how to simulate the progression of days in a week using a loop in C++. The program starts with a given day, then proceeds to the next day in the sequence using an if-else chain for each day. You can define the starting day, and the loop will update the day for each iteration. Print the current day and the next day at each loop. This allows you to track the progression from one day to the next, simulating the full weekly cycle. And as we can see, the expected output is starting day progression, current day : Monday, next day will be Tuesday, next day will be Wednesday, next day will be Thursday, next day will be Friday, then Saturday, Sunday, and week progression completed ! This example illustrates how you can use a loop and conditional statement to simulate the flow of time and displaying intermediate results and making it easy to understand how the program advances from one day to the next. Coming to the code, hash include IOStream, then using namespace std semicolon int main. Inside main, what we are doing? We are using the cout statement for debugging. So cout extraction operator in double inverted commas starting day progression dot 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 and then endl semicolon. So this statement is just to make the user understand that the program is starting now. Then string day is equal to in double inverted commas Monday semicolon, then cout in double inverted commas current day colon, then the value of variable day endl and semicolon. Now we are using this for loop to simulate day progression. That means to decide which day will come after the previous one. For int I is equal to 0 semicolon I less than 6 semicolon I plus plus. Parenthesis, the code for this for loop begins here. If day is equal to Monday, then in parenthesis day is equal to in double inverted commas Tuesday semicolon, and code for the if block ends here. That means if the current day is Monday, then the next one will be Tuesday. Then else if day is equal to Tuesday, then day will be Wednesday. Then else if day is equal to Wednesday, then parenthesis day is equal to Thursday semicolon. Else if day is equal to Thursday, parenthesis day is equal to Friday semicolon. Similarly, for Friday, the value of day will be Saturday, and for Saturday, the value of day will be Sunday. Parenthesis close for the last else if block. Then again, cout in double inverted commas next day will be colon and then the value of day. So we have given the condition that if the value of day is Friday, then the value of variable day will be updated to Saturday. So here the updated value, that means the next day, will be printed. Then endl and semicolon. Since the for loop ends after this piece of code, this whole piece of code will be executed for values of I from 0 to 5. That means the loop will run total 6 times. Then cout in double inverted commas, weak progression completed, exclamation mark, ENDL and semicolon. This is also kind of print statement debugging because it is indicating the program completion. Then return 0, semicolon, and the main function ends here. Now let's run the program to see the output. So starting day, progression printed as it is, current day colon Monday. Since we have assigned Monday as value for variable day initially, it is showing current day Monday. And after that, it has been showing the weekly progression, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and lastly it prints week progression completed, exclamation mark. This is how we use print statement debugging in C++. Now let us discuss some common bug patterns or examples in C++. First one is off by one errors. These bugs happen when your loop runs one time more or one time less than it should. For example, for in bracket int I is equal to 0, semicolon I less than equal to 5, semicolon I plus plus, bracket close, then the parentheses begin for this for block, and cout extraction operator I, semicolon, and parentheses close. So here we are starting the value of I from 0. We want to run it 5 times, but since we are starting from 0 and we are giving the condition I less than and equal to 5, so it will run till 5. So from 0 to 5 the loop will run total 6 times, but the user is expecting to run it 5 times, and that is why this is an off by one error. Next is uninitialized variables. A variable is declared but not assigned a value. So this means when you use a variable without assigning a value to it first. For example, int x semicolon, cout x semicolon. Now since we have not assigned any value to variable x, then when we try to print the value of x in output, we will get a garbage value because we have not really given or assigned any value to the variable x. Next is assignment instead of comparison. So a lot of times we get confused between assignment operator and comparison operator. When we are comparing two numbers, we need to use this is equal to sign twice, and when we are assigning a value, we have to use it once. So this is a very common mistake that we do in if conditions. Example, if x is equal to 5 in brackets and then parentheses. Now we are giving a wrong statement because x is equal to 5 is like assigning value 5 to x and not comparing the value of x with 5. Array index out of bound. It means accessing an array position that does not exist. For example, int arr, then in square bracket we have written 5 and semicolon. So here we are declaring an array which is of type integer and has total 5 elements. So this array can store 5 elements. Now the index number for these 5 elements will be 0, 1, 2, 3, 4. Then in the next line we are writing arr, and then in square bracket we have written 5 is equal to 10 semicolon. This statement means that the array element which is positioned at index number 5 should be assigned value 10. But if you see, technically there is no element at index number 5 because the index number starts from 0 and goes up to 4. So this is an array index out of bounds error. Next is infinite loops. The loop condition never becomes false, so the loop never ends. A lot of time we give such kind of condition in the loop that leads to forever running the loop. For example, while in bracket we have written true, and then in parentheses whatever code we will write, it will keep running forever because inside while we have written that the condition will always be true. Next is wrong data type usage or type mismatches. So using a data type that cannot represent the expected values. For example, float price is equal to in double inverted commas hello and semicolon. So if you see, float is a data type that represents decimal point numbers. Price is the name of the variable and here the value that we have assigned is of type string. So when we have already declared that the variable price is of type float, we cannot assign a string value to it, and that is why it is a wrong data type usage or type mismatch error. Last but not the least, incorrect loop conditions. When the loop conditions don't match what you actually want the program to do. So it is also kind of logical error. Example, while age is greater than 18. Instead of writing while age is greater than or equal to 18. So this is again a logical error. If we want to execute a piece of code only when the variable age should be above 18 or equal to 18, then we should write while age is greater than or equal to 18. But by mistake we write while age is greater than 18. So by chance, if the condition turns out to be age is equal to 18, then the program will not show correct output in that case. This is called incorrect loop conditions.
And that wraps up our discussion on code debugging in C++. You are now equipped with practical debugging tools and a solid understanding of common bug patterns in C++. Don't forget to practice using these concepts on the CodeChef platform. Thank you so much for watching.